What do you write as a reason when using corresponding parts of congruent triangles in a proof? CPs eat easy. Cpctc, CPs eat easy. I'm going to blame the book on that one. I got that one from the book. All right. So Cpctc. What is that? After, not before, after you have proven two triangles are congruent. Or if you are given that two triangles are congruent, then you can use Cpctc to show that individual parts are congruent. It stands for corresponding parts of congruent triangles are congruent, which kind of makes sense based on our definition of congruent polygons. Our definition was that all sides are congruent and all angles are congruent. So, if you know the triangles are congruent, then you can say the corresponding sides are congruent or the corresponding angles are congruent. The big part is they have to be corresponding. So, you can use, don't forget, you can use side, 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 angle, side, angle, angle, side, and hypotenuse leg to prove that triangles are congruent. And then after you prove the triangles are congruent, you can go get the other sides and angles that you're trying to get to using Cpctc. It is almost always the last step in a proof to show that the sides or angles of two congruent triangles are congruent. Did I say congruent enough times? I think I did. All right, so this is actually a flowchart proof. It's not that different from a two-column proof. It probably looks a lot different. But what we're doing is that we're looking at the pieces and we're putting them together to get to the next steps. So I know this is my given, and I can put that as my reason, given. And I'm trying to prove that these two segments are congruent, that PQ is congruent to PS. Now, I know that PR bisects angle QPS and QRS. So what does bisect mean? It means it cuts the angles in half. So I'm actually going to squeeze these both into this one little box. So I know these two angles are congruent, and I know those two angles are congruent because it bisected not only this QPS, but also QRS. So now I can write the pairs of angles as congruent. And the reason is it's a definition of an angle bisector. Notice on these flowchart proofs, instead of doing columns, where I have statement and then reason, now I have the statements are in the little boxes and I just put the reason under the box. Now I see that I have two angles that are congruent, right? I've got an angle there and an angle there. Do you see this side that's being shared by both triangles? Shared sides are automatically congruent to themselves. So I can say that PR is congruent to PR. And the reason is the reflexive property of congruence. So now I say, okay, I can say these two triangles are congruent. Triangle QPR is congruent to triangle SPR. And the reason is angle, side, angle. Now, finally, I say, okay, the PQ corresponds to PS. Since the triangles are congruent, then I can say the sides are congruent. So PQ is congruent to QS. I can put a little congruent mark there and a congruent mark there. And my reason is Cpctc. Cpctc. Anyways. All right, in example 2, ABC is an isosceles triangle, it should say triangle, with vertex BCA. So ABC is isosceles. And DAC is isosceles. DAC is isosceles. And here's my vertex angle there. We also tell you that AB is congruent to DC. Now I'm going to actually do the markings on the next slide because I don't have enough room for this whole thing here. So here's my, my drawing. And one thing you do when you have overlapping triangles, go ahead and break them apart. It may be good to leave them together. So you can, I'm using all three pictures, the pictures with them together and the pictures with them separated. My two-column proof has my statements in there. I just threw everything in one box and wrote given. By the way, I happen to throw an extra box on this one, so you only will be using the first 6. So I went ahead and marked my AB as congruent to DC. So if you're looking at it on this with the overlapping triangles, that can be a little confusing. So I went ahead and marked it on my separated triangle so you can see the two sides are congruent. And now I'm going to say, because there's two shared sides, those are also congruent using the reflexive property of congruence. So see that? These are congruent. The AC is congruent to itself. And I have a prime here, don't worry about that. So AC is congruent to AC. So I'm like, okay, I've got a side and a side, a side and a side. So I just need either an angle or a side in the right place, and I can prove the triangles are congruent. Well, I know that these two sides are congruent. BC is congruent to AC because this is an isosceles triangle, and these two are the legs. I also know AD is congruent to DC for the very same reason. So AC is congruent to BC because it's an isosceles triangle. AC is congruent to AD because it's an isosceles triangle. So now that I see that, I have side, 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 which is an excellent way to prove that triangles are congruent. ABC is congruent to CDA using side, side, side. My goal was to prove that the two angles, angle B and angle D, are congruent. Well, I can say since they are corresponding angles, then I can use Cpctc to prove that they are congruent. So triangles on the coordinate plane, you can also use Cpctc, and what you might want to do is use the distance formula or the Pythagorean theorem. I made this example really easy so we wouldn't kill ourselves, and I went ahead and plotted these points. So we're going to do a paragraph proof. What does that mean? Just write down the reasons. So I'm going to tell you what they are, and you can go ahead and write them down in your own language. So first of all, I'm going to plot everything there. So I have A, B, and C, and D. So go ahead and take a moment to plot those. And now what are we going to do? I'm going to go ahead, the easiest thing I can do, I can't really find angles yet. I'll teach you how later. But right now, I don't know how to find angles. But what I can do is find lengths. And so I'm going to go ahead and find AC. Now, I kind of, you know us geometry teachers, what are our favorite triangles? Well, this one has a length of 3 and a length of 4. So how big does the length have to be for the other side? It has to be 5. So let me go ahead and write that down. So this length right here is 5 using Pythagorean theorem. And it's really a triple that we're using. You see the 3, 4, 5? The same thing is true on this one. See the 3 and the 4. So this is a 5. Now on this bottom side, I can see that, first of all, I don't even have to count it. I know that it's congruent to itself. So I'm going to go ahead and do a mark here. And I'm going to do a mark here. So I know AC is congruent to DB. And you can write that, say, I know segments AC and DB are congruent because they both have length 5. And I found that out using the Pythagorean theorem. All right, so that's one side. I also know that AB is congruent to itself. See how it's shared between both triangles? If you need to, draw them as separate triangles, all right? And you can say, aha, these two are shared, so they're congruent. So in your paragraph, you would say, oh, I know AB is congruent to itself because of the reflexive property of congruence. Okay, so I need just one more side. Well, let me go ahead and take a look at the length of the other side, and I'll change colors here. We'll use red. All right, so looking at this length, I'm going to make a right triangle. Whoops. I'm going to make a right triangle and use Pythagorean theorem again. Well, let's see, -3 to 7. Did I do this properly? We'll find out. This length is 4. Oh, this might not be an easy one. And this length is 10, right? 7, 10. I think I'm going to have to use Pythagorean theorem. I thought I was clever, but I didn't do it properly. So 4 squared, let me go ahead and get my pen. 4 squared plus 10 squared equals 4 squared plus 10 squared equals, and I'll just say d for distance squared. All right, so I've got 16 plus 100. So d squared is 116, or square root of 116. Now, it's not really that big a deal that it didn't work out perfectly for me there, but see, if I measure the other length here, I'm going to have a height of 4 and a length of 10 too. So I know that AD is congruent to CB. And the reason I found out is I just used the Pythagorean theorem and found the length for both. So in your paragraph, I would say AD is congruent to CB because they have the same length, which is square root of 116. And you found that using the Pythagorean theorem. So that means we have a third side that's congruent, the CB and the DA. So now I can say both triangles are congruent using side, side, side.